Thank you. So in the hope that anything is going to be visible in this sunny day on the projection. So I'm Ákos Maroy, I'm from Hungary, and I'm very dedicated to flying. I actually flew here from Hungary on Tuesday. I landed at Lelystad Airport, and I'm going to talk about our project, which is called Open Aviation Maps. So, but first, let's talk a little bit about aviation navigation information and what is this really about. So, is anything visible here? Not much, huh? Okay, so I'll be seeing what I see and you're not. So, I mean, I guess what I talk is more important. So, what do you see on this picture? Nothing because it's not but still, if you can make anything out, what do you see there? Yeah, Budapest. There's a bridge, there is a river. It's kind of scenic, right? But actually, what an aviator would see is something that you guys don't see on the projection. I don't know. There's not too many of us. Maybe if you just look at the screen of the laptop, then you can actually see what I wanted to show. So please come over. So this is what you would see when you're an aviator. And this red part is restricted airspace number 1. You're not allowed to fly there. And there's the control airspace for the Budapest main airport, which means you only fly in there if you have a permission. So this whole aviation nav thing is kind of a virtual reality thing that you have to see stuff in the air which are just not there. It's the same scenario, the same area. This is the red part, which I showed on the picture. This is the CTR, this kind of yellowish part. This is the bridge, this is the river. Or the same thing with the satellite map underneath. And then these are already screenshots from our project, from the Open Aviation Map project. And this is the same with the 3D visualization. So this is like the hill in front. This is the bridge. These are the boats. If I go back to the, you see, this is the boats, the bridge, and that's the, it's called the Citadella. So that's here. And these are kind of the airspaces that are drew on the map manually. So why is this important? Navigation is important because, yeah, you need to get somewhere, so you have to be able to navigate there, right? That's kind of an important thing. You want to avoid, yeah.
Do you have the slides online?
I will.
Oh, yeah, but if you can do it now.
Sure.
We could see them.
Not, actually I have it now as well. Shall I show the URL?
Yeah, please.
Yeah. It should be here somewhere. Yep. No. This URL here, and you should see a PDF file. Okay. It's the PDF, the only PDF file in the folder. Okay. So this is kind of important because you want to avoid dangerous spaces. You want to plan your trips. You want to be safe. And the basic rule of aviation is that you aviate, you navigate, and you communicate. So it's like the second most important thing when you actually fly. When it comes to aviation nav data, so what kind of data do we have? We have airspaces, we have navigation points, which are sometimes real navigation points. So it's like there's something physical, some radio transmitter kind of thing on the ground. Sometimes you have GPS navigation points, which are points totally made up. There's no physical corresponding item on the ground for those points. We have airways, which are kind of paths that you fly through, and then we have procedures, basically, which are a series of navigation points that you have to follow. Let me show an example of an airspace definition as published by the Hungarian authority, but all of them are published in a similar manner. Maybe if I highlight this, I can't highlight it now. Yeah, so anyway, I wanted to show the text here. Basically, the text for this airspace is it's a circle radius 3 kilometers and centered on, and then there's a coordinate GPS coordinate. Now, this is how it looks in reality. That's Paks, the big nuclear reactor in the middle of Hungary. And it's a very red area. You should not fly there, period, because they get angry at you. I want to show another definition of how an airspace definition looks like. This is also something you can't read, so I'll read it up. It says it starts with a specific coordinate, then it says a clockwise arc with a 6 kilometer radius centered on another coordinate, then it is following the border of Austria and Hungary up until a third particular coordinate. And the green one is how it looks like, this one, when you actually draw it. So that's the circular area, and here it is how it follows the border. So when you want to work with airspaces and this kind of navigation info, it's even though it seems simple, you just have points and spaces. Actually, some of these definitions are quite complex in terms of you have to get existing data like a national border or a river, which sometimes spaces follow a river. So entering these spaces into any kind of a sort of geospatial database is a bit challenging. But this is what we do. So why do we need this project, this Open Aviation Map project? Like, isn't this stuff already available out there? I mean, people have been flying for over 100 years now. There's a lot of flights every day in Europe. Yeah, it's out there, but not in an open manner. So basically, the state of the affairs currently is that you have it's government agencies which will publish this kind of data. The way it's published, it's unusable. It's basically this textual description, what I read up earlier. During flying, it's very difficult to interpolate with circular angles and stuff like that, and then you don't know the national border anyway. So you can't use it as it is being published by the government. And of course, there are commercial companies who supply this kind of information to commercial airliners and stuff. It's basically there's a single monopoly who does that, and accordingly, it's kind of pricey too. Yep.
The airlines do it as well themselves.
No, they buy it from Jeppesen, from the.
Yeah, most of them do. Not all.
So. What is this project about? It's a combination of tools and data, and it's a project very much in progress. What tools do we have? So let me run down on what we have done so far. We have a set of Java tools, which are conversion tools from various formats into basically an OpenStreetMap style PostGIS database. We can also export to AIXM, which is a kind of new XML format, which is being championed by the FAA and Eurocontrol now. And then we have rendering tools which can draw the map, which I showed you earlier. We can also draw paper maps, like big paper maps with different projections, not just web-based projection, but also Lambert, Koenig, and Mercator projections. We have an Android app, so you can use it in flight, which is good. And then we have a WebGL-based prototype, basically, which is a 3D representation and running in a browser. So our Java tools, which is kind of the boring thing, so it's a lot of conversion tools, conversion routines. It's about parsing XML files or text files, and then you basically put out other XML files and text files. The funky thing about it is that it can recognize and understand some of these complex definitions, like taking a national border and combining it with an airspace part, and then it's going to automatically output the proper airspace boundaries. And we have a lot of rendering features basically set in. So what you have when you import this data in the spatial database like PostGIS, then after that you want to render it maybe to a bitmap. And how we're using a tool set called GeoTools to do that for us. And it has this styling language called Styled Layer Descriptor, SLD. And basically we have a command line tool which is just calling into GeoTools with these SLDs to render the maps. Now, only if this was so simple as I just said, because it's not. All these rendering tools, they have a lot of challenges because they were created to create map toolset, map tiles. So basically the original Google map kind of, bitmaps which are tiled together, and then you just load the new ones. Which means that there are a lot of times it's actually not good for us. Some of the issues we have is that one is labeling. So because they render it tile by tile, each tile, it doesn't know if the tile next to it is going to be rendered. So if it finds that there has to be a label to be rendered, each of them will render it in that small tile. Now, if you have a huge area, then you're gonna have a zillion labels saying the same thing, which is annoying. So then you have to do what is called meta tiling, basically create a big tile and then cut it up later, and then hopefully this double labeling issue will go away. So that's one of the issues we have. Another issue which was very painful for us is that these rendering tools, they are focused on rendering on a web onto into a bitmap, which is supposed to be shown on a browser, which is like a screen which used to be 96 dpi in the old ages. So basically, they all think of pixels. That's the basic unit of measurement, which is totally incorrect. If I take my phone, if I take another cell phone, if I take a high-res LCD, if I take a big screen, which is going to be low-res in terms of DPI, the unit of measurement as a pixel is totally useless. What I want to have is I want to have a line which is like 5 millimeters thick, no matter where I look at it. Now, none of these rendering tools that come with or that are around OpenStreetMap actually have this ability. For you to specify, say, a width of in a target device size. So we had to do a lot of circumvention, basically, like coming. Basically, we ended up pre-processing these styling documents according to the particular rendering that we want to do, and then basically we are from sort of a template styling document. We are pre-generating the styling document that's gonna work with GeoTools. And then there is another nasty problem, which means that in some cases, when and especially with the airspaces, you want to have these what you saw in it's called the internal buffer. Basically, you want to have a thickness around the airspace, like which is usually either slanted lines or if it's a transparent color. Now, this buffer definition in the styling language is they didn't really think about it when they created it. So the unit of measurement for this buffer is the unit of measurement of the coordinate reference system that is being used in the PostGIS, which is underneath the whole thing, which basically means it's a long phrase to say it's a useless, it's a totally useless unit of measurement. So we have to pre-calculate this unit of measurement into a useful target device size thing as well. So I just wanted to get back to this box image again. So basically here you can see the problems that you want to have this. So if you want to zoom out, you want to have the very same thickness of the line here, which is totally impossible with these tools now. And you want to have the same thickness for the roads as well, because just for the reason that you're looking at a larger area, your eyes are going to be the same, right? So you want to have the same symbology with the same thickness. Okay, so this is one of the big pains that we have experienced. Now, okay, so what we can do with rendering, we can render web-based maps, which you can use. We can render paper maps. This is a shrink-down screenshot of one of the paper maps that we have. This, if you print it, this is like this big. And you can take it with you. And then we have an Android app, and I'm going to show you a small video about what our Android app does. Yep. Yeah. I hope this is visible a little bit. So this is a test flight around Budapest, where we were checking out what our Android app is doing, and you can see us, the cell phone and the tablet, looking at what we have. So that's kind of reality out there. And then if it's not visible, then you can also come to the screen again if you want to. I don't know if it's enjoyable at all. Let's do that. Come here, and then you can see on the screen. Yeah, so that's my friend Aaron there, and so this is like the airport where we're taking off from, and then that's the airfield itself. So this is like the airplane, and that's the river we're flying over. So the Android version is offline because you don't have internet up in the air, and it shows your real-world position on the map itself. So you can like see where you are, and then yeah, basically navigate like that. So this is like the previous area that I showed the images from, and this is the other side of this area. You're gonna see Margaret Island in front there. And people who know Budapest, this is Váci út. So yeah, that's the main idea, that you know, have this tool in your hand and it tells you where you are and it draws you all the uh, airspaces and stuff that you need to avoid or you need to know where you're at. Okay, so here are some screenshots of the Android app as well. It's free to download from Google Store. And actually with this project, we won the open source prize, project of the year prize in Hungary earlier this year. Okay, and then we have a sort of a prototype for an additional representation, which is a WebGL-based viewer. It's based on Cesium, which is a WebGL-based virtual globe environment. So it's written in JavaScript and it uses OpenGL. So yeah, so just to show you a difference of how this, so this is like the bitmap render map that we've seen earlier. And this is basically an early prototype screenshot of the WebGL based thing. So you see the mountains and stuff, and then you see the airspace in 3D there. And this is the same thing with the, I don't know if it's visible, with the satellite imagery underneath. And I can also show you, I think I'm still in time, so I can also show you, yeah, so this is it in motion. So for example now, yeah, you can, you know, look at all the, do you see anything there? No? So I'll invite you to the laptop again. So this is, say, the same area. And yeah, this is kind of the airspace that we've been looking at. And you can like, you know, come in and you see the hills and everything. And now it's all 3D correct. Basically, it is telling you where the airspaces are and where you should go or you should not be going. And it also has, so it shows like a lot of airspace around. And it also has this feature, which basically it's a simple initial KML support where it can retrospectively show where you've been flying. So this is like an actual flight path, recorded flight path, which...
KML.
This is KML. So basically the airplane, or you can write the recorder yourself. So this is like a flight to the Lake Balaton around the Badacsony area. And for example, here you can see that this is an environmental airspace zone. And then we have been kind of skimming the top of it, a little bit into it as well. So this is the peninsula of Tihany. So it's kind of a tool that wishes to show the airspaces that your navigation points, and it also, you can use it for post-analysis. So you can like review where you've been, if you've been, you know, if you have followed the procedures properly, etc. So this is kind of a prototype thing now we have. Okay. Now, so let me talk about our aims and goals. Basically, what we're going to do now, because we have Hungary covered. Basically, what we want to do is that we want to enter all the data which is relevant to Europe. So basically covering all the 20 odd European countries. And we want to do this by converting data from this official publication. And there is a lot of data which is scattered around. Like there is an Our Airports project, which has a huge airport data set. There's this file format called OpenAir, which is non-comprehensive, but it's a lot of airspaces written there. So we want to import a lot of data from here and then kind of review it, sort of proof it to see that all the information has been entered. And then we want to create new tools as well. So currently, data entry is very tedious. We were using JOSM, which comes from OpenStreetMap, and then entering this airspace data there. It's quite laborious. So we want to have an online tool which is similar to ID for OpenStreetMap, where you could just click and just enter info through a web browser, so you don't need to download and run a specific tool for that. We want to improve on our rendering because I'm still very annoyed by how this whole bitmap rendering thing is working. And then, of course, we want to finish the 3D visualization in the browser, and then if we want to do 3D visualization in tablets as well. So there, the idea would be that you hold up your tablet or phone, and it shows you in an augmented reality way where things are. And this would be especially beneficial if you put this into a Google Glass or something like that. Then it's kind of hands-free. So you just, as you look around, you see where you're at, where you're heading. Especially useful for hand gliders, for example, because they have their hands full. They don't have a lot of. So the last slide, which is not visible either. So anyway, what we are looking for is that we need more volunteers to the project. This is basically my final point. So it's kind of an exciting and cool thing to do. But we are seriously understaffed. So we, if you fancy any of working on any of these things like spatial data or aviation data, then feel free to contact us. Thank you. Go ahead.
Have you considered involving the flight simulator community because they have the same issues?
If we have involved the flight simulator community, yes and no. I'm an X-Plane user myself. So in X-Plane, it's a cross-platform commercial simulator. So you have a lot of data there as well, but not all of. So it's kind of let me put it this way: they are very cautious about the data set they have, and they are very proud that they have collected a lot of aviation nav data throughout the years. So, and this also means that we are very reluctant to share this with anyone. That's kind of a problem. But what I was thinking about is because you can also write plugins for X-Plane, I'm sure for MS Flight Simulator as well, that basically if you know this kind of replaying a flight that you had, you could do it in the simulator as well, which is fun because it's quite eerie.
It could work both ways. They
Yeah.
give to this project in order to get their stuff in there.
Yeah, and actually just this week we got an offer from a US guy who has a similar project which runs on iOS. So basically he said that he would want to open source it, and most probably this would mean that he would join this project with his iOS app. So then we would have an iOS application as well, not just an Android one. So that would be also a big boost for Apple.
How often does this thing change? How often do you have to update it?
Yeah, these publications come out from the state authority maybe 3 or 4 times a year. And it's pre-scheduled, so it's not that imminently there is something going on, but you already know that there's going to be a new publication in September, another one in December. It's about 3 or 4 times a year per country, and the changes are already available 3 months, usually 3 months before they become effective. So you have a lot of time to gather them, and the amount of change is usually not that much. So the big push is the initial data entry, and then just updating the data with the new changes is done quite easy. Well, I took the hard route, which meant that I was parsing XML files which are not created for machine processing at all. So there's a lot of heuristics and stuff, because I thought that this is the good way to go. In hindsight, no, manual entry is much shorter. So I think this parsing code, I mean, this is a project I'm doing in my free time. So when I'm talking calendar time, it doesn't mean I was working full time on it. But it took me about 3 months free time to calendar time to write this import, which only works for Hungary because it's a lot of special cases that has to be handled because the whole documentation is a mess that they publish. So I would reckon that actually manual data entry would have worked in 1 month or less. So
how many records or how many data points do you have?
about 100. So I would say maybe 50 airspaces, maybe 40 navigation points, and officially only about 8 airports in Hungary. In reality, about 50. So there's also a discrepancy between the official publications and what's out there in reality. So it's not a lot of data points. The tedious ones are these ones which follow the river or follow the borderline, that kind of stuff.
But you have terrain data, do you get it from
Terrain data is available, and but it's when you just draw the 2D map, it doesn't help you because you just reflect the original definition, which says 1,000 feet above ground level, and then the pilot should know. With 3D rendering, you need the terrain data, but that's available. So you can use the SRTM data, or you can use the Japanese Space Agency data, and that's widely available. That's not a big issue.
Please get next speaker started. Thank you very much.
Okay, thank you.